So thanks. I have to continue also related to AI, and while Meelis is definitely core expert or very strong guy on this domain, so I belong to the group of Rain, who doesn't know much about AI. What is about? So it is the concept is very simple. So it is so if it is clear for everybody, then we can just skip this presentation and then go to next one. So it is maybe you can raise a hand if it is if you don't understand what is there. So I need at least one hand to continue. So okay, at least we have three hands. Okay. So the thing is, oops, sorry. This is the thing is that if you are talking about IT, so we very frequently forget about ICT or the communication side. And so ITL, as you know, also contains connectivity. There are telecom providers, for example, participating this union. So we essentially have to talk at least something about connectivity as well, especially because we need to get the data out we can process on the cloud. So we can't survive without it. One option where we can collect this data is IoT or Internet of Things, or in Estonian it is not so good, it is asjade internet. What is now going more important is that we should do it effectively. Effectively means energetically effectively, or effectively in this sense that we don't waste too much resources. So everybody knows that how expensive it is to do computations on cloud. So it's a huge waste of energy. And especially we should not transfer the data to somewhere in Ireland or US especially, that this is also costly. So we should do or put some kind of or more and more knowledge to this place where we generate the knowledge. And this is typically that way that we also have the outcome or the output on the same place. So if we collect information about the room climate or CO2, which is probably rather high right now, so we have to control it also here. So it doesn't make sense to transfer the data to somewhere else. What is a problem right now is that sustainability aspects are not very widely addressed so far. So we should do something more advanced to meet future goals of sustainability, green transition and thin transition. And this is possible with AI, and this is where we end up sustainable AI. So it is known to a lot of people that what IAoT means, that this is AI-based IoT, and sustainable AI IoT is what we target. And why we are dealing it with that this is attractive to the community or the stakeholders, all kind of stakeholders, because annual growth rate is roughly 30% right now, which is slightly below of generative AI, but it is very high. This is high importance in terms of usage. So what are our objectives on this project? So it is, you see that it is saying that it is contribution. So unfortunately, I don't have much clear KPIs saying that, okay, it is a million times more effective, or it is just groundbreaking new algorithms are developed or will be developed. So this is something iterative. So we contribute, we still can't compete with, let's say, Google, Amazon, something, maybe NVIDIA we cannot compete, which is largest electronics company right now. But we can do something. And this is what we expect. And the main focus is on the hardware, on the chips. So these tiny things which is you see on the right hand side below is this is our target, not these big ones. And what we would like to improve during this contribution is energy efficiency and lifetime. Lifetime, we mean product lifetime, like a sensor lifetime, including battery energy consumption and so on. Recyclability, that means that devices or hardware, some devices can be reused. And also some kind of security, safety in terms that it cannot be copied, so we can trust the information. So what are the technical or specific objects what we would like to target or what we are working with? Is that we would like to generate these tiny chips. Again, tiny chips, not the big processor chips. This is not our goal. We would like to decrease energy consumption by 100 to 1,000 times. So we can say that, okay, maybe 500 times compared to the purely digital chips. And what is the idea is that we are just combining here analog and digital technologies. So you know that previously everything was analog and it was processed in digital domain. So our target is to work it vice versa, that we gather data in digital domain and process it in analog domain. That means that instead of going with gigahertz, we can go with kilohertz. So we can just reduce the frequency of at least 1,000 times, million times. And we would like to end up with at least one chip prototype or implementation. Hopefully we'll do it more, but this is what we have right now. And this is something like also medical domain is very popular or very attractive, as already mentioned several times. Seems we all are working on the same domains. Okay, so what is now another important issue? The another important issue which is not done today is that we can generate a lot of this kind of wearable sensors, for example, or environmental sensors. But what they do, they end up with such kind of trash. And what we would like to do, we would like to support this idea it can be reused. And the idea here is that we can use a printed circuit board which can be either biodegradable or just somehow soluble in water or somewhere. And where is knowledge or where is interesting point is typically these boards are very bad in terms of electrical properties. So we would like to work with electronics to make this possible. And this is maybe one of the key aspects of our project. So here is maybe one nice example that we definitely would like to work with systems or applications as well. And here, this is one graphs of our project which is right now running, is that if we use IoT, so basically we can reduce the rotting of this wooden house. And the idea is that we can extend the lifetime of this wooden house more than 100 years, or 75 years or something. So right now this is measurements of this new, right now made modular wooden house, and it lasts only 20, 30 years. Then after that something happens. So using the previous technologies, energy efficient energy consumption, we can deploy massive amount of these IoT devices which give signals when something bad happens. And then we can easily try to avoid such kind of conditions that something bad is going to happen. Okay, what else? So also like generic ideas that we would like to extend or just at least to remain that the chip design know-how doesn't live in Estonia. So it is about to die, but we would like to keep it here. So because we used to have, it was rather high during the Soviet time, there are very good companies have been in Estonia which were very successful in world scale. So we would like to extend and keep that this kind of knowledge is not disappearing, because this chip design is one of the most valuable IT field as such. So the salaries are one of the highest salaries on the IT field. The second thing is that we definitely would like to extend the amount of embedded AI, machine learning, maybe also AI professionals. So these people are able to work with hardware. So it's, as you know, that AI is taking this general programming skills, so most likely ITL has no members anymore, because nobody needs these human programmers. But this is definitely a topic where we still cannot survive with machine-based programming or development skills. And we definitely would like to focus on entrepreneurship opportunities, because it is not, so this is one way. So we don't have such companies in Estonia. So there are about maybe 5 companies who could use our services. But we really hope that we can create some startups, and these are the most valuable startups if we consider the IT domain as such. Okay, so it is not coming from the sky. So definitely this project is based on previous activities. And we do plan to collaborate with Tartu University, and we plan to collaborate with our chemistry partners at TalTech. And we plan to engage 6 PhD researchers and hire at least 3 new PhD candidates. We also have some partners who have agreed to support the project in terms of support letters, and we will continue with this. And I guess that was it from my side. Thank you.
Thank you. Any questions from our audience? If you don't, I will ask you. You told that the system is vice versa. Initially digital information and thereafter analog treatment of that. Can you describe in detail what it means? You gather the digital information, you transform it to analog and process it later, or what is the let's say the physics or electronics behind that?
Yes. Going into detail, so it is not true in this sense that we are still sensing environment in analog domain, as you assume.
Okay.
But the thing is that the analog domain was almost forgotten during recent years. So everything is digitalized nowadays, and having some kind of sensors which measure something in analog domain and having the output in analog domains, these are very rare.
The idea is, as I understood, the idea is to let those change in system, the analog, if they are in starting collecting the information in analog form, then you process it also in simplified system, which is not digital at all.
Well, so technically you just import the signal in digital domain because most of the components around the world like digital world. But if you convert it to the analog domain, so this helps to do complex equations
more easily.
More easily, yes.
Okay.
Yes.
Thank you. Dan again. Yeah, please. It's not questions to apologize for questions.
There is an interesting application of chip designers, which is understanding. You mentioned something which I started thinking about, which is maintaining the skill set of actual chip design in Estonia. I think it's interesting and important, but I have an alternative application, which is looking at chips that others have made and determining their security properties, for example, for inclusion in critical infrastructure or defense applications. So do we have the skills for that? Can you help with that?
What we do have is there from the previous IT Academy projects, there was one team was working with these unclonable ICs. So this is something we would like also to include here, which means that if it is always people tend to clone something. So you know that you are using this RFID card, so which is used for your door openers. This is from China, you can clone this. So it is, we have certain knowledge here which helps to make chips which physically cannot be cloned.
Okay, that's designing new chips again, but looking at existing ones.
You mean that just...
Does it send all my data to another country that I don't want it to send data to?
Typically, you tend to like some kind of Chinese servers or Chinese services. So it is... this is a question of how we maintain our data. So if we have, let's say, this super secure mobile phones, so sure we can avoid using it. But typical, if you talk about these IoT devices, so these are, let's see, low-cost devices.
Yeah, I understand. It's the thing I was having in mind again was the defense industry. They have sometimes the money not to buy the cheapest chips.
Yeah, but the thing is that in militaries, information doesn't cost much in short time. So if we talk about battlefield monitoring, so it doesn't cost because lifetime of the information is so short.
More like I'm trying to avoid remote shutdowns of interesting, important hardware, but yeah.
Yeah, maybe we can discuss that.
Yeah.
Yeah. And closed doors. Yeah. Thank you.
Thanks.